On the left, a heavy farm tractor rolls easily over soft mud, while a lighter bicycle sinks straight down. The key variable is surface area. The wide tires distribute weight across a broad footprint, while the bicycle concentrates its mass onto a narrow strip. This introduces the concept of pressure. Pressure is defined as the force acting perpendicularly per unit of area. We calculate it with a simple formula. Pressure equals force divided by area. Force is measured in newtons and area in square meters, giving us newtons per square meter, a unit called the Pascal. Knowing the pressure indicates how an object will interact with a surface. It shows that the distribution of force dictates the physical result just as much as the magnitude of the force itself. Consider this wooden box resting on a floor. It has a downward weight of 600 newtons, covering a 2 square meter base area. Using the formula P equals F over A, we divide the 600 newtons by 2 square meters. The result is 300 pascals. To visualize this scale, remember that 1 pascal represents 1 newton of force spread across 1 square meter. This box applies 300 of those units to every square meter of floor it touches. This hippopotamus has a mass of 1,500 kilograms and a foot area of 0.3 square meters. We multiply mass by gravity, 10 meters per second squared, to get its weight, a downward force of 15,000 newtons. 15,000 newtons divided by 0.3 square meters equals 50,000 pascals. Always verify units before starting. When the problem provides kilograms, multiply by gravity to establish the force in newtons first. Standing in these boots applies 600 newtons across 0.04 square meters, creating 15,000 pascals of pressure. Balancing on 1 foot halves the area to 0.02 square meters. Pause and calculate. Dividing 600 newtons by 0.02 square meters reveals a pressure of 30,000 pascals. Cutting the area in half has doubled the pressure. This inverse relationship explains why focusing force onto a single point of contact, like a knife or the tip of a nail, creates enough pressure to pierce solid objects. These same principles of force and area govern the engineering of the Nalubale hydroelectric power station dam. Architects must account for pressure when designing structures that hold back millions of liters of water. As depth increases, the stacked water generates an outward force that concentrates against the lower dam wall. To counter this, the dam is built with a thickened concrete base, designed to safely absorb the highest concentration of force where pressure is greatest. Analyzing pressure allows us to predict how both localized objects and massive reservoirs will interact with the structures we build to contain them. Remember these 3 core rules. 1. Pressure equals force over area. 2. Convert kilograms to newtons first. 3. Small area means high pressure. Mastering pressure is about understanding how to distribute and control force. In our next lesson, we will explore how these laws apply to fluids and why massive ships can float on water.